Greetings of the day. Welcome to the course on operations research technique. In last lecture we have seen various methods for finding initial solution of the transportation problem. A firm which needs to optimize the objective function of the transportation problem may be minimization of the cost or maximization of the profit, will submit details of their requirement, their problem, existing problem to the OR consultant, and OR consultant is supposed to optimize the objective function in two categories. One, maximize the profit, and other, minimize the cost. In both the situation, we have to make appropriate transportation matrix from the given data, and we have seen what are the elements of the transportation matrix and how to create transportation matrix from the given data. Also, we have seen three methods for finding initial feasible solution to a transportation problem. In that, first one was northwest corner rule method, second was least cost method, and third one is Vogel's approximation method, or also referred as method of penalty. It is abbreviated as VAM. And I have iterated in my last lecture. If you are supposed to find initial solution by the methods provided, preferably find initial solution by VAM, that is Vogel's approximation method or method of penalty. And if you recall last lecture, we have solved a problem, same problem, and we could find initial feasible solution by all three methods stated, and we have witnessed that the initial solution obtained by VAM is less when it is minimization type of problem, is lower side for objective function of cost minimization. So out of these three initial feasible solution, VAM gave us minimum value, and now we were on the point of optimizing whether the solution obtained by VAM is optimal or not. I have said, if one is asking you to find initial solution by any particular stated method, you have to adopt that particular method. But if it is plain that optimize the transportation problem, always find initial solution by VAM. And I have explained why by VAM, because it takes you very close to your final answer, your final objective function. So in between, iterative steps are omitted, and your labor for calculating those tables is minimized or saved. Now today we will see first what are the cost elements we got out of these three methods for the same problem, and we will optimize. Now today's lecture is basically focused on optimizing the initial solution obtained by these three methods. Remember one thing, that your initial depends on the situation. Your initial solution may be optimal solution, or it may not be optimal solution. For that, to ensure whether it is optimal solution or not, we have to follow some method, and that method for optimization of transportation problem is called as modified distribution method. Once again, modified distribution method. Now students, from modified MO, from distribution DI, then collecting this MO and DI, a word is made MODI. MODI method, that is modified distribution method. So it is abbreviated as MODI method. And we will now see what are the steps involved in modified distribution method. Exhaustive steps are there. I have written all this those steps in slides for you. You can note down these steps, and what I will do, I will implement the written steps in a problem to optimize the given problem. So let's move. Now, if you recall our last lecture, in last lecture what we did is, as just pointed out, for this given problem we have seen what are the steps involved in finding initial feasible solution. And now here you can note, by northwest corner rule, in last lecture which we have solved, we got initial solution minimum transportation cost as 1015 rupees 1015. For the same problem, when we adopt least cost method for finding initial solution for the same problem, we got first answer as rupees 814. We have solved this. We have seen the steps involved. And when we apply, again in last lecture, just go through last lecture if you are not remembering it. When we apply VAM, so total minimum cost by VAM comes out to be rupees 779. Compare these three costs, 1015, 814 and 779. So students, in the very beginning this VAM gives you minimum cost. Now you don't know whether this particular cost, you don't know this, whether this is optimal or not. So our task in today's lecture is to check whether the cost which we got as an initial solution, rupees 779, for this transportation matrix, is it optimal? That we are going to study. So moving ahead. As I have mentioned, the modified distribution, and I have written with brown color, MODI. So from this MO and from this DI, combination of MODI method is used to calculate opportunity cost. I will explain all these terms. Opportunity cost associated with each unoccupied cell, and then improving the current solution leading to optimal solution. Students, this is my target. I want to get optimal solution. I am interested in optimal solution. Remember, this is very important. I am interested in optimal solution. Right now what I got is this current solution, which we are saying rupees by VAM 779 by which method? VAM. So there is no point in optimizing the earlier method's solution, because this is the least amongst those three initial feasible solution. So we will be optimizing this value, whether this is final or further improvement is possible. Is it possible that we could reduce this value below rupees 779? That is our task. Now in further slide I will explain this. What do you mean by unoccupied cell? What is this opportunity cost? What is occupied cell? Unless and until we are clear with that concept, we cannot understand the MODI method. So let's move. Now see here, I have given you a transportation matrix, and where now I am interested in explaining the matrix terminology to you. There are various elements in this particular matrix. If you recall again my lecture, in transportation matrix I have explained general terms. That particular transportation matrix was generalized pattern, and there I have explained you some generalized term. Now here, suppose you got, we are assuming this is the, with assumption, this is the initial feasible solution. For understanding, what we are witnessing right now is initial feasible solution for a transportation problem, and we got something structure like this. If you recall my earlier lecture, I have explained meaning of this. I have also done this circling of some numbers like that. So here first what we will do, we will try to understand the meaning of this particular words. Then only we will be in a position to understand the modified distribution method. Now allocation. To allocate some quantity to some cells. Now I will be explaining one by one. Suppose I am talking of this particular, I am marking this. This is cell. This is cell CEL, cell of this matrix, and this cell is nothing but it is S3D4. S3D4 cell, the cell which I have marked. Like if I point here, this will be cell S2D2. Similarly, there are 12 cells in this matrix. Each row is having 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. 4 3s are 12 cells. So these are not cells from our understanding point of view. We are interested in the cells where there is cost values. So we can say, see here there are cost values. So whenever we are allocating some quantity, now we know that this is the supply quantity, these are the demands quantity, and during our, in a method of finding initial solution, we have allocated minimum of the supply and demand to a particular cell satisfying the condition. So the value which is allocated, assigned to that particular cell is allocation. Here for S1D1, this 5 is allocation. Like this 8 is allocation. Like this 7 is allocation. I think you are getting it now. Similarly, 2 is allocation. This 2 is allocation. This 10 is allocation. The quantity assigned in a cell as per requirement of the initial solution or as per requirement of the solution is allocation. The quantity assigned minimum out of supply and demand, that is allocation. Got it? Is it very clear now? Allocation is clear. Now we will see second term, occupied cell. Occupied, we know generalized meaning, simple meaning of occupy, to grab, to be at place. So the cell where we have allocation is referred as occupied cell. So in simple term, cell with allocation. Cell with allocation is occupied cell. Simple. So this one S1D1 is occupied cell, S1D4 is occupied cell, S2D3 is occupied cell, S2D4 is occupied cell, S3 D2 is occupied cell, S3 D4 is occupied cell. Means for this particular problem we are having 1, 2, 3, 4, 5, 6 occupied cells. So occupied cell with allocation. For example, if I want to give for example, so this is now occupied cell. Clear? First we have seen what is allocation. Second we have seen what is occupied cell. Now students, chance is for unoccupied cell. Simple. Here I have written cell with allocation. So in simple terms, cell without allocation. Cell without allocation is what? Unoccupied cell. So for example, suppose I want to give here example. So this particular cell, example what we can quote is cell S3 D3. Cell S3 D3 is nothing but it is representing you unoccupied cell. So likewise we are having S1 D1, S1 D3, S2 D1, S2 D2, S3 D1, S3 D3 as unoccupied cell. Simple how to remember, wherever there is allocation is occupied, wherever there is no allocation is unoccupied. Simple, very simple. Now it is this is the deciding factor for optimization. This is the deciding factor for optimization. The values at unoccupied cell. We will be abbreviating here these values in the form of DIJs that I will be explaining in next slide. DIJs. DIJs values for unoccupied cell. How? So here just for your sake I will write the formula and I will explain this. So at unoccupied cell, cost minus UI plus Vj, this formula will be using. I will explain this in modified distribution method process or steps. Right now remember we have to find these values, and for objective function minimization, if we get these values as negative, then improvement is possible. Very important. That again I will be explaining in next slide. Here my intention was to explain you various terminologies related to matrix. Once these terminologies are clear, further explanation is easy to understand. Let's move. Now, see here, statements are given. Very important slide. Very important slides. Steps of modified distribution method. Steps of modified distribution method. And now again all these steps are for, again I am marking with star mark, again these are for a transportation problem with minimization type of objective function. In my last lecture, if you remember, I have explained how to convert maximization type of problem to minimization type of problem. Simple trick as we did in assignment problem. What we did in assignment problem is we have subtracted all elements of that particular matrix from highest element of the same matrix. So that gives you relative loss matrix or minimization type of matrix, but interpret your answer from original matrix, that is original maximization type of matrix. The concerned step we will see in the slide where I will be dealing with maximization type of transportation problem. Now here, this is very important slide. If you understand each and every content of this slide, solving transportation problem will be very easy for you, dear students. Step 1 says, for an initial feasible solution with m plus, this is very important. Now, how many allocations you should have at the beginning when you find a solution by initial method? Number of allocations must be equal to m plus n minus 1. Now I will explain this. What is the m plus n minus 1? Suppose I am having this matrix. Now here, for this from to this 2, there are 3 rows and 4 columns. So rows are specified, denoted by m, columns are by n. So if I am getting initial solution to this particular transportation problem, for this case m plus n minus 1 will be equal to 6 for this case. You may ask, sir, how you have calculated 6? So students, m is 1, 2, 3 number of rows, n is number of columns 1, 2, 3, 4. So m plus n, 3 plus 4, 7, 7 minus 1, 6. If number of allocations you are getting is equal to this, then only we can attempt to solve that particular problem. Else that is called as degeneracy in transportation problem. Which word I am using? The word degeneracy. It is not possible to solve that problem further unless and until we overcome degeneracy. It can be overcome, no issue. But without, how the problem of without degeneracy will be there? For that, number of allocations has to be equal to m plus n minus 1, m number of rows, n number of columns. Then what is given? Calculate, these terms are very important, students. Now ui and vj for rows and columns. We will be doing all these things in our exercise, actual solving the problem. To start with, what is saying? Any one of ui's or vj's is assigned the value 0. That is very important. Now these u's are for, all u's are for rows and all v's are for columns. Since it is row, they are referring at I stands for, I goes for row, and v's, vj, it goes for column. So I can write here u i's vj's. You can give any ui vj 0 to start the problem, but what one should do is, you can again find this with color marking. it is better to assign 0 to a particular UI VG where there are maximum number of allocations in row or column. I can make my habit of assigning all U1 every time U1 equal to 0 and solve the problem. No harm. Answer will not go wrong. Only additional steps may be increased. But if you follow this condition that you are having matrix, allocation matrix, so assign that particular row or column, that we will be doing when we will be solving problem. I will be reminding you this particular step. Okay, we have seen this in step. We can do this, but we are doing this because it was mentioned in the step like this. I will remind you at that point of time when we will solve this problem by Modi method. Now, once that is done, then what we have to do? This is important relation. The values of UIs and VJ, very, very important. In previous slide, I have written Cij is equal to Ui plus Vj. It is for all occupied cell, and I have explained you what is the meaning of occupied cell. We will be calculating these values of Ui and Vj by equating it to the cost of that particular occupied cell. Again, this may be, you may find this difficult to understand by reading the slide. I will thoroughly explain this while solving the problem. Then for unoccupied cell, calculate opportunity cost. Yes, this is very important. If you remember in my previous slide, for minimization type of objective function, if this cost is negative, your solution is not optimal, improvement is possible. That I have only mentioned, and here I will explain in detail. So for this unoccupied cell, how we are calculating the cost? We are abbreviating this opportunity cost as DIJs. Our abbreviation for understanding purpose, all opportunity cost we will indicate as D, to be represented by D, a letter D, which is equal to cost minus Ui plus Vj for all I and j. But for which cell? For all unoccupied cell. This formula, with this formula you have to calculate Ui and Vj for occupied cell. But opportunity cost you have to calculate for unoccupied cell. That is very important. And then very important, examine sign of each Dij, which is nothing but opportunity cost. Examine sign of each Dij. Repeatedly I am telling you, Dij is what? Opportunity cost. Dij is opportunity cost. Examine the sign, means whether it is 0, whether it is plus or minus. Accordingly, we will decide whether the solution under test is optimal or not. If you are getting all values of Dijs, that is opportunity cost with positive sign, if Dij greater than 0, when you will get students positive sign? It's very simple. When the values are greater than 0. If you are getting all values of Dij for unoccupied cell positive, your current solution under test is optimal. Transportation algorithm terminates. What I am saying? Transportation algorithm, of which we have computer programming, it terminates at that point of time. Instead, if you are having this value equal to 0, then current physical cell solution is optimal, but there are chances or there is other solution to the same problem, meaning you will get the same answer, same value, but allocations may be different. That is the case when it is 0. And importantly, I have mentioned with very bold letters in brown color, if one or more, even one or more than one Dij is less than 0, the meaning of Dij less than 0 is nothing but if they are negative. If they are negative, any one value is negative or more than one value is negative, improved solution can be obtained, means the current solution is not optimal. Got it? These are detailed steps for modified distribution method. And steps further goes if you face this situation. Your problem ends with this first condition. But if you are having this sign negative, you have to further solve the problem. Transportation algorithm doesn't terminate. Let's move ahead. Now, in step 4, suppose you are not getting, again, have these steps written in your notebook, because when you solve problem, you need to read these steps and apply these steps while solving problem. So it is essential that you must have these steps written in your notebook. It says construct a closed path. Again, what I will be repeatedly telling is, I will thoroughly explain these steps, written steps, while solving the problem. Construct closed path or loop. Remember this word. For the unoccupied cell with largest negative, we have to select the largest negative value of Dij. Start the closed path with selected unoccupied cell and mark that particular identified cell as positive sign. Trace a path along rows and columns of unoccupied cell. Mark corner with minus and other with plus. All these will be explained when we will be solving problem. Once we draw closed loop, next step is select the smallest quantity amongst the cells marked with minus sign on the corner of the closed loop. Now suppose I get closed loop like this, and suppose this is my starting point. So starting point is to be marked plus, alternate corner minus, plus, minus, plus, minus. So this is what we have to do when we will be solving problem. What is the meaning of this particular sentence that I am explaining? Now here with this minus 1, 2, 3, you are having 3 cells with minus sign, and those cells represent allocation. So amongst minus sign corner cells, we have to select the value which is cell which is having minimum value. And what we will do, what for we are doing all this task is, we want to improvise the solution. So simply what is to be done is, suppose again by example I give it 2, 4, and 5. Suppose at minus sign you are having values 2, 4 and 5. So it is to be treated as minus 2, minus 4, minus 5. So logically smallest quantity with minus sign is minus 5. If you compare minus 2, minus 4, minus 5, definitely this minus 5 is the smallest one. What it says? If you are coming across this, add that value, smallest value amongst minus cell to the cell wherever there is plus value. Now it is with this minus cell smallest value. If you neglect sign, only identify values, then you have to add that particular value to a cell with positive sign, to a cell, subtract that value to a cell from a cell with negative sign, and keep other values of the matrix same. So again this step will be explained to you when we will go for actual execution of the transportation model problem. Now obtain new improved solution by allocating units to the unoccupied cell according to step 5. We have done something in step 5, so you have to obtain new improved solution. This particular step will give you new improved solution. Once you got new improved solution, your task is again test for optimality. Test optimality of the revised solution. The procedure terminates when all Dij greater than equal to 0. That we have seen. If all values are positive or 0, there is no need to solve that problem further. The solution under test itself is optimal solution. So these are exhaustive steps for modified distribution method. Now once we are through with these steps, our task is to apply this in real life problem. Now what we will be doing? We will be studying the same problem for which we have calculated initial feasible solution. This is the same problem, and we got initial solution for this problem by VAM. And if you recall by VAM our initial solution minimum cost was rupees 779, if you recall that. And here the objective function is find minimum transportation cost. So students, we have done some part of this problem already while explaining the steps. Now we will go ahead. Ahead means we will go ahead of this 779, whatever solution we got it. We will be optimizing now this particular solution. Now how to proceed? So see, this is initial solution by VAM. If you recall my previous lecture, I have gone through each and every step, and there we have done all this business. And in my last lecture, you can go through that slide. We have literally solved that problem here in our regular class, and Here I am taking snapshot of what we did in for saving the time, because this is already done in our previous lecture. So now we have to optimize. Our target is to optimize this particular cost. Our target is to optimize this particular task, this cost, that is 779. We want to optimize this, and just now I explained, for optimization we have to use modified distribution method. We have to use modified distribution method. Clear? So now we'll move how to go for various stepwise for that Moody method. Now here you can see the preparations done for this problem. Here the values of cost were 19, 30 from previous problem, 50, 10, 50, 10, supply was 7, then 70, 30, 40, 60, 40, 60, then 48, 48, 70, 20. This was original given cost in the matrix, and we have found initial solution to this problem in last lecture, where at this point we have allocated 5, at this point we have allocated 2, at this point we have allocated 7, here 2, here 8, and here 10, and these values were 9, 18, then demand were 5, 8, 7 and 14, like that. So here supply and demand was 34 by 34, like that. And now I am not interested in these cells, therefore I have crossed it. Now it's very important how we should proceed. See, now this is very important point. What we are doing is we are applying modified distribution method. Now you have to be very correct. What I have said in our previous lecture, that for occupied cell, cell cost is equal to UI plus Vj, our last discussion. So these are the occupied cell, 1, 2, 3, 4, 5, 6. Before that, what we have to check when we are optimizing this, we have to check first whether number of allocations are equal to m plus n minus 1. If this is satisfied, then only we can go for this optimization concept. So students, here do not count these rows, actual rows of supply, actual columns are demand, that is m, actual columns are requirement or demand are n, actual rows of supply or origin are m. So here 1, 2, 3, m is, for this case m is 3, n 1, 2, 3, 4, m plus 1 minus 1, this comes out to be 6. Now we will count number of allocation, 1, 2, 3, 4, 5, 6, yes. condition is satisfied. Means now we can move with finding initial solution. We can move now finding initial solution. Again, for your understanding, I will write here the formula, so that will be very easy for you to understand. For occupied cell, cost is equal to UI plus Vj. And recall my lecture from the last slide. I have said that throughout problem you can take u1 0. If u1 0 means this is u1, this is u2, u3, v1, v2, v3, v4. If somebody takes, okay sir, I don't bother, every time I have decided I will take ui, that is u1 0. Is it okay for me? I will say yes, okay. But chances are you may have more number of steps involved in problem solving. What the step we have discussed in previous slides. So take that particular u I or Vj equal to 0 where there are maximum allocations. Now see here there are 2 allocations for this row, here there are 2 allocations for this row, here there are 2 allocations for this row, for this column 1, for this column 1, but for this column 3 allocations. So what we will do, we will take this particular value of V4 equal to 0. Is it very clear? U4 equal to 0. And now apply this logic. Apply this logic. But this logic is only for occupied cell. How to find values? Cell to cell now we have to move. See, once you take this 0, see why we have taken this 0? Because there are maximum allocation. So this is now occupied cell. Since this is occupied cell, and for occupied cell cost is equal to ui plus vj. So for this occupied cell 10 is the cost, means from this formula this cost 10 is sum of ui plus vj. This 10 is equal to here ui means u1 plus vj means v4. So 10 is equal to u1 plus v4 is 0, means u1 equal to 0. So students, here I will write u1 equal to 10. Got it? Like this you have to find remaining values of ui and vj for all occupied cell. Again, occupied cells means where there are allocations. So now you have to follow the link. Do not miss the link. See now, you are ready with this value. We will do this first for all these values. This is also occupied cell 20. So 20 is sum of this plus this. This is u3. Guess what will be u3? Anybody? Yes, it is by this logic. u3 will be 20. Similarly, u2 will be, it is 60 is sum of u2 v4 is 0, so this will be 60. So you are ready with values of u1, u2, u3. Now we will calculate values of v1, v2 and V3. How? See here, this is a location, means this is occupied cell. For this occupied cell cost is 19. So 19 is, for 19 you have calculated U1 as 10. So 19 is sum of 10 plus this value. You don't know this value. So which value plus 10 gives you 19? So here it has to be 9. So 19 is equal to 9 plus 10. One thing very important, if any one value goes wrong, if any one values of U and UI and Vj goes wrong, remember your entire labor will be wasted, because these values of UI and Vj's in next iteration, in next calculation will be deciding your opportunity cost, Dij cost, which decides whether the problem is optimal or not. So you have to be very careful while calculating UI and Vg. Now here, for this is occupied cell with value 8. So here 8 is sum of this, 8 is equal to, here I will write this 8 is equal to sum of V2 plus this is 20. So what is that value of V2 which will bring this to 12? So definitely V2 will be equal to minus 12. So minus 12 plus 20 will be 8. So here it is minus 12. See, again I am repeating, these are very important calculations. And last, V3 is equal to, this is 7. 7 is sum of 60 and some value. So what is that sum value? Again it will be minus. So minus 53. Minus 53 plus 60, difference of these is 7. So we are now ready with different UI value and Vj value, and in next iteration we will find remaining values of opportunity cost. So today we will end this lecture at this point of time, and from next lecture we will move ahead with finding the values for remaining cells, opportunity cost.